All right, welcome to The Explainer. Today, we are diving into one of the biggest bottlenecks in all of AI, and that's just how insanely expensive it is to train these models. But, a brand new breakthrough might be about to change the entire game. So let's just start with the question that is on every single AI developer's mind. I mean, this is the multi-billion-dollar problem everyone is racing to solve, right? How in the world do you train a giant AI without needing a giant supercomputer to do it? Okay, so to train an AI, you need this special tool called an optimizer. You can kind of think of it like a teacher or a guide that helps the model learn from all the data you feed it. The problem is, for years, researchers have been totally stuck in this fundamental trade-off. The paper we're looking at today calls it the efficiency-structure dilemma. And that dilemma really boils down to a pretty painful choice. On one side, you've got these fast, but let's be honest, kind of dumb methods. They just plow through the data without really understanding it. Then, on the other side, you have these really smart, sophisticated methods that get the deep patterns in the data, but, oh man, they're incredibly slow and just outrageously expensive. So for the longest time, the question has always been, do you want to train your model fast, or do you want to train it well? This whole dilemma has basically created two rival camps, two completely different ways of thinking about AI training. So let's meet the contenders. All right, so first up on Team Speed, we've got ANDI. This is the workhorse of modern AI, for sure. It's fast, it's efficient, but it has a big blind spot. It totally ignores how all the different parts of the model are related. The analogy I love is an orchestra, where every musician just tunes their own instrument really quickly. It's fast, yeah, but the final sound, it can be pretty chaotic. Then you've got Team Structure, with methods like muon. Now, this is like a perfectionist conductor who stopped the entire rehearsal to personally tune every single instrument in relation to all the others. The result is beautiful, perfectly harmonious, but it takes forever. And look, this isn't just a nice story. The math backs it up. ANDI's complexity is what we call O of n, or big O of n. All that really means is that the cost to run it grows in a straight, predictable line as your model gets bigger. Totally manageable. But muon? Its complexity can skyrocket. It grows exponentially. As the models get bigger, the cost just explodes. And that's why this smart approach has been, pretty much impossible for most projects. But what if you didn't have to make that choice? What if you could get that perfect harmony from the conductor, but at the lightning speed of the individual musician? Well, a new paper introduces a brand new optimizer that claims to do exactly that. It's called ANDI. That's short for Adaptive Norm Distribution Interface. And the idea behind it is actually surprisingly simple, but really, really powerful. So, what's ANDI's secret sauce? It's a technique called additive equilibration. Let's go back to our orchestra for a second. With ANDI, it's like each musician makes a quick little adjustment, not just on their own, but based on the volume of their entire section. The violins, the brass, and the specific musical part they're playing. It's this super fast local coordination that creates a balanced, beautiful sound without needing the conductor to stop and do all those crazy complex calculations. It just keeps any one part of the model from getting too loud and drowning out everyone else. And it works in this really elegant three-step process. First, ANDI measures the energy, you can think of it as the importance, of the information flowing through the model's connections. Then it uses that measurement to balance everything out. And finally, it just adjusts the overall magnitude to make sure everything stays stable. It's like it's constantly rebalancing the whole system, but in a super efficient way. And here is the absolute knockout punch. Look at the complexity. It's ON. It's just as fast and efficient as the simple ANDI method. But at the same time, its special technique, this rank 1 additive thing, gives it all the smart, structured guidance of the much slower methods. It is, literally, the best of both worlds. Okay, so the theory sounds amazing, right? But the real question is, does it actually work out in the real world? Well, the researchers pitted ANDI against the reigning champions from both Team Speed and Team Structure. Let's take a look at the results. And wow, here are the results. When they trained a GPT-style language model, the kind behind things like ChatGPT, ANDI, that's the solid red line you see there, just takes off. It learns so much faster. And it's not just about speed. Look where it ends up. It reaches a lower final loss, which basically means it created a better, more accurate model in the end. It beat both the fast guy, ANDI, and the super complex smart guy, muon. But here's the real kicker. What did all that amazing performance cost? Practically nothing. Check this out. On this specific task, ANDI finished in 108 seconds. That is just 5 seconds slower than the standard, less effective Atom W. Meanwhile, the smart optimizer, Demion, took a whole 127 seconds. So you're getting a state-of-the-art result for pretty much the same price as the basic option. That's insane. And we're not just talking about small lab experiments here. The researchers went big. They tried this on a massive 8 billion parameter Llama 3 model. And look at this chart. ANDI shows what the paper calls a fast start phenomenon. That red line just dives down. It starts adapting and learning like crazy right from the get-go, while the old standard, Atom W, is just kind of stuck at the top. Okay, let's zoom out. What does all this actually mean for the future of AI? Why is this such a big deal, and not just another paper with another optimizer? Well, the authors themselves put it perfectly. They say ANDI hits a Pareto optimal point. Now, that's a fancy term, but all it really means is that it's found the perfect balance. It's a solution where you can't get any better on one thing, like, say, training quality, without making something else worse, like speed. ANDI nails that sweet spot, giving you all the advantages of smart training without that crippling cost. It doesn't just manage the trade-off, it completely breaks it. So what's the bottom line? ANDI could be a complete paradigm shift. It means we can train better models, faster and cheaper. This could easily become the new gold standard for training models like transformers. But maybe the most important thing is this. By crushing that computational barrier, it could finally make building powerful, cutting-edge AI accessible to everyone, not just the handful of companies with giant supercomputers. This isn't just about making the AI we already have a little bit better. This fundamentally changes the entire economics of AI development. It really makes you stop and think, right? If training powerful AI suddenly becomes this much more efficient, what new possibilities, what incredible applications that we always thought were just too expensive or too slow? What is now finally within our reach?